Alright, we're going to determine the most precise classification for quadrilateral ABCD. It could either be a parallelogram, rectangle, rhombus, or a square. The first thing we need to do is figure out if it's going to be a rectangle or parallelogram rectangle or rhombus or square. So we first need to figure out if the sides are congruent or not. So first what we have to do is AB, we're going to compare AB, which is 3, -4, and then 10, -2. We're going to use the distance formula here. So D will be equal to the square root of x2 minus x1. Next is subscripts. So I'm going to use the distance formula here. So the distance formula, D equals x2 minus x1 squared plus y2 minus y1 squared. Alright, so I'm going to use that. So I have this is equal to 10 minus 3 squared plus -2 plus 4 squared, which is equal to 7 squared plus 2 squared, which we get 49. So that would be 49 plus 4, which would be 53. Yep. So we'll keep it as a square root, 53, just to keep it simple. So that's for AB. Now we're going to do BC. B is at 10, -2, and then we have C is at 8, -9, x1, y1, x2, y2. So what we have here, D is equal to the square root of 8 minus 10 squared plus -9 plus 2 squared, which we get the square root of -2 squared plus -9, -7 squared, which we get that is equal to, for that, square root of 53. Kind of see these are next to each other from our, so it's most likely a rhombus or square so far. But then we need to do C and D. C is at 8, -9. D is at 1, -11. So D is equal to the square root of, okay, x1, y1, x2, y2. The reason why we always do this is just to keep ourselves organized. I'm going to move this up so we can continue to keep working. So what we have here is 1 minus 8 squared plus -11 plus 9 squared. And you get this is equal to -7 squared plus will be -2 squared, which would be equal to 49, 4, we get square root 53. Last but not least, we have DA. D is at 1, -11, and A is at 3, -4, x1, y1, x2, y2. We get D is equal to the square root of 3 minus 1 squared plus -4 plus 11 squared, which is equal to 2 squared plus -7 squared, which is equal to square root 53. Alright, as you can notice, the same. So those are the same. So now we have to check the diagonals. So the two choices we have is it's either a rhombus or a square. So it's either a rhombus or a square at this point. So now we're going to be comparing AC, because A to C, if you want to, let's just give you a visual, I guess. We don't know what it's going to be yet. We can just draw like that. We have A, B, C, D. Now we're checking the diagonals. So from A to C and then B to D. We just got to see if If the distances are the same, it's a square. If the distances are different, then we have ourselves a rhombus. So AC, we're dealing with 3, -4, and then C is 8, -9. Alright, I'm going to move it up a little bit, and we'll write down what we're doing for the other part. So AC, this would be D is equal to the, x1, y1, x2, y2, square root of 8 minus 3 squared plus -9 plus 4 squared. So you get this is equal to 5 squared, -9 plus 4 plus -5 squared, which you get square root 50. Alright, so we have square root 50 for this one. Now, we want to find the distance between B and D. B is at 10, -2, and D is at 1, -11. x1, y1, x2, y2. So what we're going to do here is we have D is equal to the square root of 1 minus 10 squared plus -11 plus 2 squared, which is equal to -9 squared plus -9 squared, which is equal to the square root of 81, which is equal to 162. These two are different, as you can notice. Since they're different, the only logical answer here is a rhombus. So for number 28, we have a rhombus.